All right, so the first thing we're going to do is a Punnett square, a monohybrid. Mono means one, so this would just be looking at one trait such as height. So if we're looking at the pea plants, we know that tall is dominant to short. And let's say that dad is heterozygous and mom is short. All right, heterozygous, hetero means different. So when it says that they're heterozygous, and we'll use a big T for tall and a little t for short, then we know that he has different alleles. So he has a big and a small. Mom is short. Well, short is recessive, and the only way to be short is to have two recessive genes, because if she had a big T, she would be tall. So she's going to be little t, little t. So we just fill in. Okay, and like I said, I always like to do all three genotypes, but you can do just the ones that are there if you want. And you can also do this in percentages, which would be 0, 50%, 50%. And then your phenotype ratio, tall to short, would be 2 to 2 or 50, 50 if you did percentages. Okay, so that's a monohybrid. Biggest thing is make sure you're confident in your parents. You don't rush through figuring out what your parents are, because if your parents are wrong, everything's wrong, and you'll lose all of your points. So you want to make sure you take time there. All right, a dihybrid, di means two. So now we're going to look at two traits at the same time. So we're going to, again, look at tall versus short. Okay, so tall is going to be dominant, so that's going to be a big T. Short's going to be a little t. And brown versus blue, as I assume. Brown is dominant, blue is recessive. Both parents are heterozygous for both traits. So for dad, we know that he is big T, big B, little b, because it just told us he was heterozygous, or he had different alleles for both traits. Mom is the same. This is the hardest dihybrid you can do. This is the longest, most extensive. So if you can do this dihybrid, then you can do any dihybrid. All right, the first thing, and this is the hardest part, not hard, but most important part, as always, is to figure out what potential sperm and egg can mom and dad make. What are the different combinations of genes we could see in their gametes? So, and we do the FOIL method. We're stealing that for math. First, outer, inner, last. So we do the first T with the first B. We do the outer T with the outer B. We do the inner T with the inner B, and the last T with the last B. Okay, mom is the same. So we'll put all those on there. And then I'm going to slide this up and over a little bit. Once we get them on here, I'm going to move all of that over so that you can see the whole Punnett square. Okay. So you just want to put one parent here and one there. It doesn't matter which parent goes where. You're still going to get the same final answer. And when you're filling in your boxes, you want to keep your T's together and your B's together. And you want to always put the dominant first. So for example, in this one, we have a big B and a little b. We want to put the big B first. Okay. And all I'm going to do is I'm going to keep filling those out, just double checking to make sure that I'm filling them out correctly. This is something that you will kind of speed up with more practice, but do not feel like you need to rush through it, because I'd rather you go slow and get it right than to rush through it and get it wrong. There's no points for being fast. Well, you do have a limited amount of time on the AP exam, but other than that, there's no points for being first or last. B, B. Little, little, big, little, big, little, big, little, big, little, 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 big, little, and little, 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 all littles. Okay. So for our genotype ratio, what we want to do is we want to write down all of the ones that are here and tally up how many of each are present. So I'm just going to start with the first one. Okay. And then I'll look at this one and I'll say, is it the same or is it different? Nope, it's different. So I need to write it down. Don't forget to put the tally mark for the first one. A lot of people forget that because they write it down and they kind of in their mind, that means 1, you got to put the 1. All right, T, B, whoops, B, and big, little, big, little. Okay, this one, do we already have it? We do. So we just add a tally. This one, do we already have it? We don't. Do we already have this one? Yes. Do we already have this one? No. Okay. Big, little, big, big. Yep, we have that one. Big, little, we have that one. Little, little, big, big. We don't have any little, littles. So we know anytime we have a little, little, that's going to be a new one. Big, little, yep. Big, little, 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 yep. Little, little, big, little, yep. And all littles is new. Okay, so that's all you do. You just tally up what's there. The last thing we need to do is we need to translate it back to our phenotype. So what we want to do, and I'm going to try to squeeze this in down here, is we want to do our two dominant phenotypes, tall and brown, and then we want to do tall with our recessive. Okay, so basically we do tall with each option. Then we're going to do short with each option. So we're going to do short, brown, short, blue. Okay, and then we just look at these and we translate them back. Okay, tall and blue, tall and brown were dominant. So this is big T for tall, big B for brown, and there's one. Big T for tall, big B for brown, and that's 2. So you want to make sure you transfer the same number over. Tall and brown, 2 more. Tall and brown, 4 more. Tall and blue. Is this one tall, but no big B, so that's blue. Tall and blue, 2 more. Short, so there's no big T, so it's not tall. So short and brown is 1. Short and brown, 2 more. And then short and blue is 1. Now you can always double check yourself because there are 16 boxes. That means that this should add up to 16. So 1, 2, 3, 4, 5, 9, 10, 11, 12, 13, 14, 15, 16. Good there. And this should add up to 16. 9, 10, 11, 12, 13, 14, 15, 16. You can also change these to numbers and say that that's a 9 to 3 to 3 to 1 ratio. You may also have to convert it to percentages. To do that, you would just do 9 divided by 16 times 100. 3 divided by 16 times 100, and 1 divided by 16 times 100. So that's the way you would convert that to a percentage. And that is how you do a monohybrid and a dihybrid Punnett square, including making sure you've got the parents correct, you've got the children correct, you do the genotype ratios and the phenotype ratios with both numbers and percents. You need to be able to make sure you can do all of that. If you still aren't sure, still don't feel great about it, still have questions, let me know.